This is episode 6 in a multi-part series on NHibernate. In this episode, Chad will take a look at the various types of collections within NHibernate and some of the features it offers, such as loading, sorting, and pre-filtering of the data.
So NHibernate supports a number of different types of collections. Bag, which is basically an iList that's not sorted and may contain duplicates depending on how well your query is formed. Bag is probably the most common just because it doesn't have a lot of requirements. Set is like, a mathematical kind of set, if you're familiar with that term. It's not necessarily an ordered set, but it is a unique set. So if your query happens to return duplicates, you're going to have a problem with that. A list is actually specifically ordered, by index. So if you had customers that were ranked and you needed to load them in a specific order by their rank, you could use a list and it'll come in. Or if you had like steps in a recipe, this is step 1, this is step 2, this is step 3. I have an order or an index column, and then the description of the actual step in my recipe. You can use a list and you tell it which is the index column and which is the value column, and it will make sure everything's loaded in the correct order. There's a lot of other options. I mean, we could spend a whole hour just talking about the collections thing. Bag is just like a straight, list or an array. Like it used to be an array list, but now it's a list of T with .NET 2 generics in .NET at least. And then for a set, there's actually no native set built into .NET. There's a hash set, but it's not quite the same thing. So NHibernate is actually dependent upon, I can't see it here, but it's actually dependent upon a third-party open source library that has these kind of data structures. It's IESI .collections. So it's actually distributed within Hibernate. You have everything you need there. And it's, from what I've heard for people who use sets, it's pretty decent. So, and it's open source and it's freely available. But if you had a different set implementation, you can tell NHibernate about that, and it would use it. So you probably have to do a little bit of plumbing to make that work. So for this, what I'm going to do is I'm going to go back into customer, and you may remember we have an iList of orders here that I've initialized automatically just in case we're using this entity and not using NHibernate. I need to know that orders isn't going to return null all the time. And in the mapping, I've actually mapped it as a bag just to keep things simple. And I have to tell it what the property name is. It's going to automatically figure out what the type is, the iList of T. I'll get to the cascade here in a minute. And I'll get to inverse also. One nifty thing about NHibernate on the collections, there's a few different things you can do here. You can actually have it automatically order things for you. If you know that this collection's always going to be, or pretty much every time I want it by default, I want it ordered this way, just kind of as a convention, you can hard code it here. You can override it. You can, hey, it's an iList, you can just use link and sort it, or use array.sort, or there's probably a dozen different ways to sort things in .NET, so you can certainly do it that way. But this will actually grab it. It'll actually issue the order by to the database. The database has to do all the sorting. There's one other option which you don't see here. Excuse me. Which is where. So you can actually have a where clause here. For example, I don't ever want to see orders where deleted equals 1. So deleted must equal 0. Deleted orders, as far as I'm concerned in my domain, don't even exist. They're deleted. But for whatever reason, maybe SOX compliance or audit trail or something, I can't actually delete them from the database. I need to leave them in there. But my application doesn't know that and doesn't care about it. So, we've come up with a system where we added a deleted column, and I just tell NHibernate that, and my application's none the wiser. It never sees deleted items, period. So for the bag, since we're going to tell we're going to relate to the order. The key column, this is a little out of order, and Hibernate makes you do it backwards, but we're going to say it's a one-to-many relationship. So there's actually a few different relationships. Let me cover that in a second. And we're going to say it's a one-to-many, so one customer, many orders. And we're going to tell it what the class is, so it can actually go and hit the order class, and it finds all its mappings. Now, which column in the order database do I need to match my customer ID against? In order, basically, what's the join column to get from to order back to its parent customer? So that's what that is. So you can actually back to the types of collections. There's a one-to-many. There's a many-to-many, which basically I could have many customers related to many orders, and I have to have a join table in the middle. Some people I've gotten into some semantic arguments with people that there is no such thing as a many-to-many relationship. It's actually two one-to-manys. Yes, you're right, but logically that join table almost doesn't exist sometimes, and it just has two columns in it. You can make it do that, or you can get something more elaborate. And Hibernate's pretty flexible there, depending on how you structure your kind of many-to-many. It also has a many-to-any, where you may have a table that represents different types of orders, which may get mapped. And Hibernate actually has the ability to. This is something I don't have in my outline. I should probably come back to that, but has the ability to map different .NET classes, .NET entities to the same table, and you can discriminate. Like if our orders, let's say there was another column called amount or something. Oh, do I have an amount? Or no, I'm sorry. Yeah, there's an amount, and I could say anything with an amount over 1,000 is a high-end order. Actually, it'd be more like if I had a type column, and the orders for goods or the orders for services. So if the column name has the string services in it, then that maps to a .NET object called services order, and if it's a product, it maps to a product order. And so in this case, what I might want to do is say many to any, where it can load up any of those types of objects. I haven't really messed around with many to any, so I'm probably not representing that correctly. I probably shouldn't talk about that very much. I'm sure I probably just made a mistake. But the ones I usually use are one to many and many to many, which covers pretty much every mapping scenario I've run into. So once we have that, and like I said, it's lazy load by default, so you can turn that off if you want. Now, you notice the cascade's a little bit different than what we had here. You still have the same kind of options: save and update, delete, and then all delete orphan, or there's an all, and there's an all delete orphan. So all is generally what you want for a parent-child relationship. So orders don't exist in this world unless they're attached to a customer. And when you update the customer, you want to, if you add orders to the customer collection and you just save the customer, it will go and save all the related orders. It should go and save all the related orders. But we added one extra thing here. We said, not only when I remove an order from a collection do I want you to delete it, but if I delete the customer, I want you to go find all the orders and delete them too, because otherwise they're going to be orphaned. So, and Hibernate will actually manage the orphan problem for you. So, and then the inverse, let me jump real quick to order, and this will explain inverse. So order is a pretty standard class: order ID, amount, product name, quantity. I have a link back to the customer. So let's look at the map here. Pretty much the same as all the other ones. The only interesting thing here is the many to one back to the customer. And I have a cascade, save and update, just like customer to store. And so the thing here is, if I want to add an order to a customer, I can actually do it a couple different ways within Hibernate. I can set the order's customer property to the customer, and then save the order. And the next time I load the customer and lazy load the orders, or call up the orders, that order will appear. I don't actually have to add it to the customer's order collection. If I want to do it that way, which is slightly more natural, I want to add the customer to the order collection. If I don't tell in Hibernate how the mapping works, it's not going to automatically just save that. So it gets kind of complicated. I'll show you here in a second kind of what I'm talking about. But basically, the more you tell NHibernate about how your relationships work, the more it's able to do automatic stuff for you. So in this case, we have a many to one, and then we have basically the inverse of that, which is the one to many. So what we need to do is tell NHibernate, by the way, it won't automatically figure this out. I'm not sure why it can't do that. I'll have to ask. But what you're basically telling it is, say, hey, there's actually another relationship over there, and it's the exact opposite of this one. You need to treat them the same way. And so NHibernate will actually be able to do some more intelligent things there and make your code look a little cleaner, so you don't have to do a bunch of hoops just to get around NHibernate.